As we look at TCP's headers here, and there are headers aplenty, we've got source port and destination port, that we expect. We also have a sequence number and an ACK number. We talked about those. We got to have those. We got some flags in there. We got a window field. We got an urgent field. We got a checksum field, data offset. We don't need to know what all of these are right now at this point in your studies, but you will admit there's a lot going on here before we get to the data, especially compared to UDP's header, which is source port, destination port, linked, and checksum. And that's it. The data's right behind that. So this gives you the biggest clue possible as to what that one word is. We've been kind of hinting about what's UDP's advantage over TCP if TCP has all those great features. Well, if you send letters and cards on a regular basis, you probably drop them at your country's post office, but you could use an overnight express service for every single one of them, whether it be FedEx, UPS, doesn't matter. But why don't you do that? Because it costs a lot, and that would add to your financial overhead. And that's the word we're looking for here. That's the big difference when it comes to TCP versus UDP. Why don't we just send everything via TCP? Because it costs us more. It doesn't cost us financially. It costs us with a lot of extra overhead that starts to slow down our network, and especially when it comes to voice and video traffic. Because, our end users have like a zero tolerance for anything botching that up. We'll hear about that right away. And TCP would just add a monster amount of overhead to that. And that's why we use UDP for voice and video traffic. A couple of notes here. The two headers do have three fields in common: source port, destination port, and checksum. That's worth knowing. And in the TCP header, I listed a flags section. That's actually 9 individual 1-bit flags, which include the ACK and SYN flags mentioned throughout this section. And I'll mention one more flag here in a few minutes in another discussion. If you want to see what every single flag is in there, that's great. And you find that out on Wikipedia or really one of 1,000 other sites. Just put TCP flags in your favorite search engine, and you'll find out what all of them are very, very quickly. Here's a little similarity, though, and I know the addresses are a little small here on this one. That will not be the case throughout the rest of the videos, I promise you. And the addresses, the IP addresses, are not really what we're concentrating on here. Now, UDP and TCP, they have a little something called multiplexing in common, multiplexing that is. And before we see how it works, let's talk about why we need it in the first place. IP addresses are used as a destination when data is sent to a network host. It's perfectly fine. We know our packets have an L3 address and frames have an L2 address. When one host sends multiple flows of information to the other host, how is the recipient supposed to handle that? It's not going to be enough for the recipient to say, hey, I got all this stuff from 10.1.1.11, so I know what to do with it. Because in this example, we've got a file transfer via the trivial file transfer protocol. We've got email via the simple mail transfer protocol. And we've got web page data via HTTP. So it's not enough for the recipient of this data to just know where it came from in order to know how to handle it, what application should be handling this information. And that's where the well-known port numbers come in. This is a series of reserved port numbers, and we're going to be introducing you to a few here, and we'll be using a few of those throughout the course. And they are reserved for certain protocols, because the server or the recipient has got to have a way to keep those incoming flows separate. And it knows, okay, when data comes in on this port, then this is the application that needs to handle it. And I'm going to have a bigger list of these well-known port numbers for you later in this section. And there is some memorization involved there. I'm not going to lie to you. But the great thing is, as time goes by, and that includes in this course, I don't mean years from now, as you're working with them, as you're studying them, they do become second nature. It's just like the OSI model. At first you may have to think of a little acronym or something to help you remember the OSI model. Don't use one in a job interview. It makes you look bad. But during the exam, it's fine. But once you start working with the OSI model, you don't even think about it. You just know what it is. Now, the 3 data flows in this example will have the same source and destination IP addresses, but they're going to have different pre-assigned, well-known port numbers. And in this case, TFTP is on UDP port 69, HTTP on TCP port 80, and SMTP on TCP port 25. So let's go down a bit here, and this is exactly what we end up with. 3 different flows of traffic. And when a host gets data marked as UDP port 69, it knows the traffic should go to the TFTP application and so forth. Now these port numbers also allow the host to mix the three data types, the sending host, because what would happen if we didn't have these port numbers and the data was all mixed up? Then the recipient gets it and goes, well, I don't know what this is, I don't know what this is. It doesn't sound like a very efficient networking to me. We want our sender to be able to mix the data as it's being sent out. We would never want to tell the host, okay, send all TFTP data first. If there isn't any of that, send the SMTP data. If there isn't any of that, send the HTTP data. What we allow it to do is mix it via multiplexing. So you end up with one data stream that actually has three streams in it. There's an SMTP stream, a Telnet stream, and a TFTP stream. It does not make that sender wait until all of one type of traffic is sent. Multiplexing allows us to mix that. Now when you hear the term socket, you might think of a physical part not only of a network host but of course of a handheld tool. But in networking, the term socket is actually logical. It's simply a combination of the IP address and the port number. The socket for the TFTP traffic heading for 10.1.100 would be expressed as 10.1.100 69. The way I like to do it when I'm writing some sockets out is IP address, transport protocol, port number. You should be used to both formats. Be ready to see either one on your exam. Using this mode of expression, the TFTP socket on 10.1.1.100 would be 10.1.1.100, UDP, 69. Now, the well-known port number system, works beautifully, obviously, as long as the hosts agree for the port given on a given protocol. That's where the well-known part comes in. Because if we had, 3 hosts in our network, yeah, right. But if we had 3 hosts in our network and one thought Telnet was TCP port 23, and another one thought it was UDP port 486, and another one thought it was TCP 1001, that would not be good. So the deal with the well-known port numbers, 2 things I want you to know about them right now. First, any port number below 1024 is a reserved well-known port number. The really good news is you do not have to memorize 1024 port numbers for your exams. But I do have a few here for you to memorize, and then you'll see them throughout the course, and they will become second nature to you after we talk about the TCP four-way handshake. What? Yeah, I know, and I promise not to do that again. But seriously, I know when that came up on the screen, it's like, now there's a four-way handshake? Are you kidding me? I'm not kidding you, and I didn't want to hit you with this during the TCP UDP comparison. You may not even see this particular handshake referred to on your exam, but you're going to see why I want you to know about it literally in seconds. Because if you're reading another book, it's a non-certification book, you're reading about TCP on the internet, you always want to use more than one source of information for your studies, even if I'm the first one. But I want you to know that the four-way handshake does exist, because I get tweets on once in a while. It's like, well, I thought you said it was three-way. The one during the construction of that underlying channel is the three-way handshake. The four-way handshake is the connection termination. Just as TCP has an orderly process for building that underlying communication, it also has one for tearing it down, and that is a four-way handshake. Now, one thing you'll see in your network studies, you'll see 3 different explanations of things from time to time, and this is one of them. I have seen this four-way handshake expressed in several different ways over the years, but in the end, what has to happen is that each device needs to send a segment with the FIN bit set, and they have to each acknowledge the FIN that they're getting. So the details of the four-way handshake, you don't have to be concerned with those like you do the three-way handshake. I guarantee you that's going to show up on your exam in one fashion or another. But I wanted you to know about this one more just in case you happen to see it referred to in TCP documentation. Definitely want you to know what's going on there. A couple of good port numbers to know here. TCP 20 and 21, both used by the file transfer protocol. You definitely want to keep FTP and TFTP separate in your head. The trivial file transfer protocol runs on UDP port 69, and speaking strictly as a Cisco admin, you're going to use TFTP more often than you'll use FTP. And what happens is TFTP servers, we use those for several different purposes, as you'll see throughout the course. So just keep those port numbers straight in your head. TCP 22 belongs to Secure Shell. TCP 23, we're going to be all over that one in this course. That's Telnet. We got plenty of lab work coming up with that. TCP 25 is your simple mail transfer protocol. DNS does use TCP and UDP ports 53. The Dynamic Host Configuration Protocol, DHCP, uses UDP port 67 and 68. HTTP, we know, is on TCP port 80. The Post Office Protocol, current version 3, runs on TCP 110. SNMP, the Simple Network Management Protocol, is UDP 161. Secure Sockets Layer is TCP 443. Syslog, I'm mentioning that here because there's system logging, plenty of that in your ICND2 studies, and that's on UDP 514. And finally, we do have a DHCP 4 IP version 6, and that uses separate ports than the DHCP I mentioned before, because that is version 4, IP version 4, and those two ports are UDP 546 and 547. Again, it's a great list to get started with, but it's hardly all of the well-known port numbers. Wikipedia has a full list of them. You can find them just about anywhere. Wikipedia is a great place to start with those port numbers. If you want to take a look at the list, beautiful, but again, you do not have to memorize all 1,024 port numbers, or however exactly many there are right now. That does conclude this particular section. Thanks for watching, and I'll see you in the next video.